Hi, Algebra. Welcome to our last lesson in Algebra 1 for the year. We are in section 12.8 looking at the parabola vertex formula. And I'm going to actually do some kind of tough math with you to show you how the parabola vertex formula is derived. You won't have to be able to replicate this right now. However, it will help you to see where it comes from, that it wasn't just made up out of nowhere. And so I just want you to follow along as I go through it. If you want to write it with me, you can. That might help you. It's in your book also, but it's hard to follow in your book if you don't understand what they're saying. So it might be hard for you to follow having me do it. I don't know, but do your best, and then when we get to the end, we'll talk about the actual vertex formula itself. So we've been looking in this chapter at graphing with this form of an equation. And so our function is all set up so that I know exactly how to graph it. I know what the stretch is going to be, or if it's going to be squished, like if it was a half or something. And we learned that if we're subtracting from the x before it's squared, that's the amount we're going to move right. And then we know if it's adding, then that's the amount we're going to move left. And we know that whatever's being added or subtracted over here tells us how far up or down we move. And so the vertex for this would be at 9, 2. Because this would make me go right 9 with my vertex, and then up 2 with my vertex, and that's where my parabola would start. So this is what our goal is, to get this form. So we have a quadratic here, but I can't look at this and tell how to graph it because it's not in this form. So we're going to take this generic function and put it into this kind of form so that we can see what is here and what is here, and that will help us be able to know where the vertex is. So our first step is to separate. We're going to take this ax squared plus bx, and we're going to separate it from the constant. So we just have our x terms in there, our x squared and our x terms in there. Now, I'm going to stop writing f of x there, because I don't need to. Now, I'm going to factor an a out of here, because I just want an x here. I don't want a number being multiplied by my x. So the trick with that, really, when you factor out a number, you're just dividing by that number. So if I divide ax squared by a, I'm left with x squared. This one, there's no a term, so I have to write it like this. So it's over a. So this would be dividing it by a. I've divided by a. So now look, if I distributed, I would have ax squared, and then this a times the bx over a. The a's would cancel, and I would just have bx. Okay? So that's my next bit of fanciness. Now, we are going to use the completing the square concept that we covered earlier this year. So when I'm completing the square, remember this term is twice the term that's in the problem that's getting squared. Like if I had x squared plus 6x plus 9, remember this is half of 3. So this would be x plus 3 squared. The 3 is half of that, and 3 squared is 9. Okay, so I am going to be completing the square using this. So I need half of this, And then that gets squared like this. B over 2a, that's half of b over a, okay? Because I'm just multiplying it by a half. That's why my 2 is in the denominator, and there was a 1 up here, but I don't need it. Okay, and that gets squared. That would be just like if I had a 6 here and a 9 here, or I guess this would be a 3, and this whole thing would be a 9, to kind of look at it like this. Okay, this whole thing represents the 9, and this in here represents the 3, which is half of the 6. Now, I can't just add something because that changes the equation. So I'm also going to subtract that term, which seems weird, but I'm going to subtract that number. So I added it and I subtracted it, which is the same as doing nothing. Like if I give you $5 and I take $5, you're left with nothing. So that's the same thing. And then I have my plus C out here still. Okay, I'm sorry about that. Okay, now I'm going to square these terms. So I have a times x squared plus b over ax plus b squared over 4a squared, because I squared the b and I squared the 2a, minus b squared over 4a squared. And I'm going to do 2 steps at once here. So if you are, no, I'm not. Sorry. I'm going to just do 1 step right now. So I've squared these 2 terms. Okay. So now I want to just look at this because that's my perfect square. So I need to have it kind of sitting by itself. So this is going to seem kind of weird. I'm going to distribute the a to just this term so I can take it out. Okay, so I'm distributing the a to just this term so that I can take it out of the parentheses. So I'm left with ax squared plus b over ax plus b squared over 4a squared minus a times b squared over 4a squared plus c. So all I did was multiply that one by the a, and I took it so I could take it out of the parentheses. Okay. Now I can simplify this so that a and one of these a's can go away. So I have b squared over 4a. And I can factor this. This is a perfect square, so it's x plus b over 2a. Remember, it has to be half of this. So b over 2a is half of this, because it's b over a times a half. Remember, that's my half. That's that number I used up here when I was completing the square. Okay, and then I'm left out here with a minus b squared over 4a plus c. Okay, you with me? Maybe not, but that's okay. All right, so now I have a times quantity x plus b over 2a squared. And then this, I don't want to leave it like that. It's a little bit complicated. So we're going to use what we've learned about rationals and get a common denominator. So my common denominator is going to be 4a because that's what I have here. So I'm going to be taking my negative b squared over 4a, and I'm going to add 4ac over 4a. Do you see how that is still c? Because the 4a and the 4a cancel, I've just multiplied by my 1. So that I have a common denominator. And that means I can put those together on top. And we're going to take this negative and just apply it to b, the b squared, because that's what it goes with. It's saying that this thing is being subtracted, but this is added. So I have a negative b squared plus 4ac over 4a. Okay, so we started up here with this, and we used math. We used all of our rules. We didn't break any rules of algebra to get us down to this form. Now remember before when we had that like a is not a good way to put it. Let's look at our f of x. We'll look at our example. 3 times x minus 9 squared plus 2. Remember, this was our y term. This was our y term. And this, subtracting 9 meant that my x was a positive 9. Oh, sorry, you can't see that. There we go. Subtracting 9 meant that my x was a positive 9. I was going to go 9 to the right. So look at here. This is a positive b over 2a. So that means that my x term is negative b over 2a. And my y is this term here. Negative b squared plus 4ac over 4a. Now, the nice part is that I can simplify this formula a little bit, because if this is x, then my y is really going to be f of x, f of negative 2b over a. So in your book, you will find the vertex formula, the parabola vertex formula. As negative b over 2a, comma, f of negative b over 2a. So this is your y, and this is your x, and that gives you the vertex of your parabola, that point. So a and b come from ax squared plus bx plus c. So this number out here is your a. If there isn't a number, remember it's 1, and your b, and if there isn't a number, it's 1, okay? But those are what you use in there. I am not going to take the time to do the example for you because the video is getting kind of long. But they give you an example here, because all you're really doing in this lesson is finding the vertex of the parabola. So you don't have to do any of that fancy stuff that I was just doing. My whole point of showing you that was to show you how we get that formula, that it wasn't just plucked out of thin air. So you're not expected to be able to replicate it at this point. However, some point in your mathematical career, you may be asked to. It just depends on what you do in math as you get older. So I had to do that when I was in like theoretical algebra classes in college. But most people aren't going to have to do that. But I like knowing where something comes from. I think that helps to know where something comes from so that you're not just plugging stuff in. Some of you might not have cared at all. That's okay. I can handle that. All right. So notice they give us this function. Okay. And so it's a parabola. So it's a quadratic equation. Okay. So I am going to first find x. That's what I'm going to do first. So I'm going to do that negative b over 2a. So b was 8. So negative b is negative 8. And then 2 times a on the bottom. A is 2. So on the bottom we're doing 2 times 2. So then you go over and you just get that x is negative 2. Okay? So then you take that negative 2 and you're going to put it into your function for x. Okay? So that's what they do down here. They find f of negative 2. So they put -2 in for x. Your biggest thing here is to make sure you pay attention. When you square a negative, it becomes a positive. Okay, but here, this would be 8 times -2. So this becomes 2 times 4 minus 16, because 8 times -2, and then the plus 4. And then you just keep going until you figure out what your y term is. And then that goes there. And then you write your vertex using your x term and your y term, or your f of x. Okay? So you'll be finishing up doing this lesson, and then over the next couple of days, you will do your reviews that are on there. And I will make a video that has the answers so you can check it. I'd love to see your final review, because it's a really good check of how well you understood the concepts for the year, and it's not super complicated from just me glancing at it. Obviously, it's not going to be as complicated to me, but I feel like it really checks for the basics to make sure that you're leaving algebra with a good, solid foundation of what that looks like. Okay, so have fun. I've really enjoyed teaching you guys this year. I'm going to miss you so much. Have a good day. Bye.